Hello. Today we are being introduced to radians. So hopefully after watching the video, before you got to this section in this video, you kind of have a little bit of an understanding about a radian. The radian is just another measurement of the circle, right? We're usually used to using what we call degrees, right? That's what you're used to seeing, but today we're going to be using radians. So again, remember a radian is the measurement relating to a circle. Right? There's a special relationship between the circumference and the diameter, no matter how big the circle is. So the circumference divided by the diameter is pi. Right? So it takes a little more than 3 diameters to go around a full circle. In a semicircle, right, half a circle, the circumference of a semicircle divided by the radius is pi. So it takes a little bit more than 3 radii to go all the way around, which is 180 degrees. So no matter what, you take any circle, you take its circumference divided by the diameter, it's pi. So a radian is how many, again, radii it takes to go around the circle. And again, if you watch the video before this one, that should make more sense to you. So, if we're looking here, some of the common conversions we're going to use, right? 360 degrees is 2 pi radians. So it takes a little bit more than 6 radii to go all the way around the entire circle. So 180 degrees would be pi radians. It takes a little bit more than 3 radii to go around half a circle. It's actually 3.14. So 90 degrees is half of 180. So half of pi is pi over 2. Okay. 60 degrees goes into 180 3 times. So this would be pi over 3. So you're going to see we're going to use 180 and 360 pi and 2 pi a lot to help us figure out a lot of these. 45 goes into 180, right? How many times? 4 times. And 30 goes into 180 6 times, so it's pi over 6. So these are the common radian values you're going to use a lot. So sometimes you're going to go back and forth between radians and degrees. So how do you do that? Well, 180 degrees is pi radians. So if you want to go from radians to degrees, you multiply by 180 over pi. So if you're looking at the example here, right, the 7 pi over 10 times 180 over pi, the pi is reduced, right? 10, the zeros reduced, so it's just 7 times 18. If you want to go from degrees to radians, it's pi over 180. So here, again, the zeros reduce, so you get 25 pi over 18. So you're using the conversion 180 equals pi radians. So we're still going to be using our 3 trig functions. We're still going to be SOHCAHTOA, sine of theta, cosine theta in terms of x, y, and r. All of that's the same. So everything we learned from the very first 4 sections still applies. It's just now instead of using degrees, we're using radians. We're using a different unit of measurement. That's the only difference. So we're going to still sketch angles in standard position. We're still going to find sine, cosine, tangent. We're still going to use reference angles. Still going to use the reference triangle. All of that is still the same. So today we're just kind of practicing getting used to radians because you've never seen it before. So we're going to sketch in standard position, which we did with degrees. Figure out the quadrant of the terminating ray, which we did. And what is the reference angle? We've done all this, but now we're in radians. So 6 pi over 5. So remember, when I did this in degrees, I would always label 0 in like 180 degrees, right? In like 360. I would always do that to help me figure out where the sketch is. But we're in radians, so we're not going to do 0 and 180, we're going to use 0, pi, 2 pi. So this is 6 pi over 5. So this would be 5 pi over 5 because that reduces to 1 pi, right? And that's 180 degrees. This would be 10 pi over 5 because that equals 2 pi, which is 360. So that means I just get past 5 pi over 5. So I'm here, right? I'm in quadrant 3. This is 6 pi over 5. How much are you past 5 pi? You are 1 pi over 5 past. So the reference angle is pi over 5. And what you're going to start to see is when we do this, it's going to start to be just always pi over 3, pi over 4, pi over 6. Because it's going to be 30 degrees, 60 degrees, 45. All right? Theta equals 5 pi over 9. So remember, this is 0 and 2 pi. And this is pi. But I'm working with fractions. So it's always nice to rewrite pi in terms of the fraction you're working with. So our fraction is ninths. So this would be 9 pi over 9. Because that reduces to 1 pi. So instead of writing 2 pi, right, this would be 18 pi over 9. Because that reduces to 2 pi. So I know from 0 to 9, so I don't make it all the way over to pi. I don't make it to 180 degrees. Well, this, if you went from 0 to 9 up top, then that would be 4.5 pi over 9, right? Because from 0 to 9 is 9. Half of that's 4.5. So, again, from here to here, right, is 9 pi over 9. Halfway would be 4.5. So that means I'm into quadrant 2. And theta prime, right, if this is 5 pi over 9, it's still to the horizontal line from the terminating ray to the horizontal. So how far is it from 5 pi to 9 pi? It's 4 pi over 9. But you're going to start to see those as we go on in later lessons. That's going to be always, okay, pi over 3, pi over 4, pi over 6. Today we're just getting used to sketching in radians. So you get more comfortable with it. Wait, 23 pi over 10. So this would be 10 pi over 10 because we're working in tenths. So then 2 pi in terms of tenths would be 20 pi over 10. So I know I go all the way around one time. But I don't make it back because from here over, right, from here to here is a distance of 10 pi. So I'm half of that, 15. So I don't make it all the way there. I'm into quadrant 1. So this is 23 pi over 10. So here's my reference angle. That distance back, I know I'm in quadrant 1. Theta prime would be 3 pi over 10. Because from 23 to 20 is 3. Remember, your reference angle is always positive. So as I do this, I'm always going to write pi and 2 pi in terms of the denominator, the fraction I'm working with. Because you're working with fractions. So it makes it a lot easier if you have common bases. It just makes it visually easier for you to see. All right, so come in here. So 16 pi over 9. So this is 0. This would be 9 pi over 9. And you're like, well, how do you keep doing that? All you do is, what's the denominator? Whatever that number is, right at top and bottom, pi. And then how do I get 2 pi? I double what I just wrote. So this would be 18 pi over 9, which is equal to 2 pi. So that helps me as a reference as I sketch this. So I know I don't make it all the way around one full rotation. Because that would be 18 and I'm at 16. So I'm in quadrant 4, theta prime. So if this is 16 pi over 9, what is this angle right here that I'm shading in black? Well, how far is it from 16 to 18? It's 2, so 2 pi over 9. Okay, well now these are negative. Uh-oh. It's the same thing. We go clockwise now, just like degrees. So this would be negative 5 pi over 5. This would be negative 10 pi. So that means I don't make it all the way over to 180 degrees. I'm in quadrant 3. So what's theta prime? Well, this is negative 3 pi. So what's the distance? This is my reference angle, the part I'm shading in red. How far is it from negative 3 to negative 5? 2 pi over 5. And it's positive because the reference angle is always positive. So I'm telling you right now, you've got to be able to write 0 and 180 and 360 in terms of your fraction you're working with because it makes it so much easier. So theta equals negative 5 pi over 3. So this would be negative 3 pi over 3. This would be negative 6 pi over 3. Right? So if you go all the way around, that's negative 6 pi over 3. Right? We're not going that far because we're at negative 5 pi. So I'm in quadrant 1. Theta prime, right? How far is it from negative 5 to negative 6? 1 pi over 3. And this is what the ones you're going to start seeing more often are going to be like number 6. Because they're going to start being pi's over 3, pi over 4, pi over 6. But again, it helps if you're rewriting pi and 2 pi in terms of your denominator. It makes it so much easier. Wait, example 2. Find the complement of each angle and then the supplement. So remember, complement means they add up to 90 degrees. So for us, that's pi over 2. Supplement is 180 degrees. So for us, that's pi. So think about it, right? If I told you one angle was 30 degrees, and what's the complement? So it's 30 plus some angle equals 90. You would just subtract, right? 30 from 90. That's how you get the complement. Well, we're working in radians. So whatever your angle is, plus some angle, equals, in this case, pi over 2. So our angle is 5 pi over 12. So I'm going to subtract. I take pi over 2 and subtract 5 pi over 12. I'm going to take 180 degrees and subtract 5 pi over 12. That's going to give me my complement and my supplement. So in order to subtract, I need to have common denominators. So this would be 6 pi over 12 minus 5 pi. So this is just pi over 12. This would be multiplied by 12. So 12 pi over 12 minus 5 pi. So that's 7 pi over 12. Right? Same idea here. Right? 2 pi plus some angle equals pi over 2. So I just subtract. But instead of just having to rewrite that numerous times, just know you have pi over 2. So subtract 2 pi over 7. So need a common denominator in order to subtract. So this is going to multiply by 2. This is going to be multiplied by 7. So 7 pi over 14 minus 4 pi over 14. So 3 pi over 14. And then we have pi over 1 minus 2 pi over 7. So same idea, multiply by 7 over 7 because I need a common denominator. So when you do that, 7 pi over 7 minus 2 pi, you get 5 pi over 7. And again, are you going to be seeing a lot of the complement, supplement, and positive and coterminal angles? Not really. But this is just getting you extra practice being comfortable working with fractions and radians. Because it's different. It's new. You've never seen it before. So to find coterminal angles, remember, usually we rotate 360 degrees. But we're in radians, so we're going to use 2 pi. So I'm going to take 2 pi over 5, and I'm going to add 2 pi. And I'm going to take 2 pi over 5, and I'm going to subtract 2 pi. Right? Because it's one full rotation. So this is a little bit more work than degrees because you have to have the same denominator. So I'm going to multiply by 5. So this would be 10 pi plus 2 pi is 12 pi over 5. So this needs a 5. So this is 10. So 2 minus 10 is negative 8 pi over 5. So 3 pi over 8, add 2 pi. 3 pi over 8, subtract 2 pi to get one full rotation. So I'm going to multiply by 8 over 8 for both of them. So this is 16. So 3 plus 16 is 19 pi over 8. This is 16. 3 minus 16 is negative 13 pi over 8. So again, understanding we're still doing one rotation, but since we're in radians, it's 2 pi. Again, both of these two examples are just getting you more comfortable working with radians. What you really need to understand is example 1, how to sketch it in standard position. Please make sure you answer the essential question with a 3 to 5 sentence summary. Once you've done that, then you're done with your notes. Have a great day.